because it is very ionic. It can give out electrons easily, and it can make ions very easily. So that was the neutralization for ethanoic acid. Now an acid like HCl, when it will react with Na2CO3, it will give NaCl plus H2O plus CO2. So any acid, when it reacts with Na2CO3, gives out your H2O and CO2, and it gives a salt, and this CO2 is evolved. So ethanoic acid should also follow the same reaction, and it does. Plus Na2CO3 it will give your CH3COONA plus H2O plus CO2. Now this is the same like HCl reacting with Na2CO3, just that in place of NaCl over here, you have CH3COONA, and so this is the reaction, and this CO2 is evolved as effervescence. So when you have to test a chemical, suppose you get an organic compound X, and it's given that X on reaction with Na2CO3 gives effervescence, and CO2 is colorless and odorless, so it can also say that it gives out a colorless and odorless gas. So identify X, and it's given that X is an organic compound, so you can't have HCl and H2SO4 and all. So this X should be an acid, because only acids on reaction with Na2CO3 give effervescence. So X is an acid, and it is an organic compound, so it has to be an organic acid like methanoic acid, ethanoic acid, propanoic acid. So actually X can be HCOOH, CH3COOH, C2H5COOH, and so on. All the acids, not only ethanoic acid, will give effervescence, will give this reaction. If you have, suppose, propanoic acid, you have C2H5COOH, just change this to C2H5COONA, not a big deal, and this will be called sodium propanoate, like ethanoate. And this reaction is very useful. Actually, you have another reaction with, balancing this reaction. You have a 2 over here, should have a 2 over here, and so we have C2H5 twice, COO twice, H2, CO3. Yeah, now it's balanced. And C2H5, or we were talking about ethanoic acid, so CH3 COOH on reaction with NaHCO3 will also give the same products, CH3COONA plus H2O plus CO2. So this is the same, I mean the reagents are different but the products are same. So balance this reaction. You will have a 2 over here, no, not a 2 over here. You have carbon dioxide and 3 carbons, 1, 2, 3, 4, 5 hydrogens, 2, 5 oxygens, it's already balanced. So this is the same reaction. Let me write this better. This is your sodium carbonate and this is sodium bicarbonate. Now these reactions are very important in distinguishing ethanoic acid or rather any acid. Suppose you get a question like you have ethanol and ethanoic acid. How would you distinguish them? In one test tube you will be given you will be given ethanol, and in one test tube you will be given ethanoic acid. You have to identify in which test tube which compound is present. So first what you will do, ethanol will not give this reaction and ethanoic acid will give this reaction. So you add a little sodium bicarbonate or sodium carbonate to both the test tubes. So in one test tube there will be effervescence of this CO2 and in one test tube there will be no effervescence. So you directly get that the test tube in which the effervescence is there is the test tube containing ethanoic acid. So this is a useful test to distinguish ethanoic acid.